This one, we are doing composition of functions, and then we are doing inverses. And so how composition of functions works is we did this kind of the algebra of functions right before the last exam, where we did adding functions, subtracting functions, dividing them, so on and so forth. And so the last thing, or one of the last things we like to talk about with functions, is saying, okay, we went through all of that algebra, the adding and the subtracting and stuff like that. But what we can also do is we can take a function and actually plug that entire function into another function. So to see that in practice, here I'm actually going to do probably part B first. So I have these two functions. I have this g and I have this f. And we see kind of two ways to represent composition of functions. One is what I see here, and actually this is kind of how I prefer to write it. This g of f of x all kind of plugged into one thing. The other way that we sometimes see it is kind of this Goff or this Fogg thing, where it's, I don't know if there's a quick way to do this, but essentially I take g, I put this tiny circle here, maybe just making it small. Oh yeah, that works. I put this tiny circle here, and that means that I'm taking my f of x and I'm plugging it into g. So these are both the exact same thing. Sure, it's helpful to know both notations. I tend to just try and focus on using this notation. But as always, WebWorks might be a little bit different, or sorry, MyMathLab might be a little bit different, and maybe there will be one question on the exam written like this. But long and short of it is those are the exact same thing. Okay, so what is this? What are we actually doing? So I have g of f of x. What this is telling me to do is take my f of x function. That's x squared minus 2. I take that entire function, that is my input. So I'm going to take this entire function, I'm going to plug it into the x value of my g. So that's kind of why I like this notation. It's telling me my input's f of x, so I take that entire function, I'm going to plug it into my entire formula for g. And so that will look like 2 times my f value minus 1. Again, to reiterate, all I did was, okay, my g is my overall function. I'm plugging my f function into that. And so this x squared minus 2 just to replace the x on my g of x. It's kind of weird because we have a lot of x's flying around, but really this is just evaluating. We've seen this before, like I just plug 2 into my function, I'll get a result. It's just weird here because now I have to, instead of plugging in a single value, I have to plug an entire function. And then once I've done that, I just kind of do the little bit of simplification if necessary. So I have 2x squared minus 4. And so I get 2x squared minus 5. And this is my final answer. Which is another reason why I think some people struggle with is that it's not a nice answer of 4 or something like that. It's still a function at the end of the day, but that's perfectly fine as long as you're doing the process correctly. Actually, quite often we don't get a just nice answer of a single value or something like that. Any questions about this first example? Okay. Now this problem hopefully will again feel a little bit similar to what we were doing with that the algebra functions when we were adding and subtracting them. So when we did those, we talked about how, I think I focused more on the multiplication. We talked about how we had two options. We could multiply the two functions out, which may have to do a little bit of foiling and a little bit of simplification, and then we could plug in the actual value into that result. Or we could take each piece, plug in the value, get the numbers, and then multiply. So same type of concept here. I have two options. I can either find my f of g of x by plugging in my g function into my overall f function, finding what that is simplified, and then plugging in 2. That's one option. In my opinion, that's a little bit worse than what we're going to do. Or I can just find my g of 2 first, get a number, and then take that number and plug it into f. So almost as an aside, I say, okay, there's a lot of stuff going on here. Let's just find g of 2. I go through like a two-step process. Okay, g of 2 is not too difficult to find. I plug 2 in for x, solve. 2 times 2 is 4, minus 1 is 3. And then I take this result and plug it into my f. So then this question becomes, instead of f of g of 2, it says, okay, well, I know my g of 2 is 3, so really I have to just find f of 3. That's also not too terrible. How do I find f of g, or f of 3? Maybe it is too terrible.
We just put in the replace x with the 3.
Mm-hmm. So I take my function f, replace the x with 3, and then solve. 9 minus 2. And as a reminder, this notation, f of g of 2, is the exact same thing as if I wrote this as f parentheses g of 2. These are the same thing. Any questions about this? Great. So we covered how things work with equations. Well, what else are we going to cover? We're going to cover how things work with tables, how they work with graphs. So let's start with tables. So here I have a table of values. This is all this is doing. It's kind of a weird way to represent it, but all this is telling me is, let's say that I want to find f of 2. So I would take 2, I would come to here on my chart and say, okay, this is where 2 happens. Maybe I want to fill it with nothing. This is when x is equal to 2. Well, what's the value of f at that value? Okay, f of 2 is equal to 5. So it's a weird table, but that's just how you use it. The top thing is telling me what my input is, and then I find the top value, match it with the actual function, and that gets me my result. So with that in mind, anyone have an idea about how I might find f of g of 7?
You'd find what g of x is equal to at 7 first,
Mhm.
which is 3. And then from there, you'd find what f of 3 is equal to.
Yeah. And this kind of two-step process happens a lot with these composition of functions. So instead of finding f of g of 7, well, let's just find g of 7. Okay, I think you said what that value is, but come to 7. At 7, g is equal to 3. And then, okay, now that we know f of, or what g of 7 is, we can rewrite our question saying, okay, f of g of 7 is the same thing as just asking what is f of 3. 2 steps. First thing, I find the value of the inside, then I find the value of the overall thing once I know the value of the inside. So what's f of 3?
Is 8.
Yeah, so let's come to the input is 3. So my value of f at that input is 8. So I conclude that f of g of 7 is equal to 8. Any questions about that? Cool. Are things happening in the chat? Where did my chat go? Okay. Onwards. Surprise, surprise. As I mentioned, we went through the actual equations. Honestly, this is probably what we'll see the most of when we talk about composition of functions. It's nice to actually have, well, functions to mess around with. That doesn't mean we can't use tables. That doesn't mean we can't use graphs, but the process is mainly focused on equations. But here, now we have three things. I have my f of g of h of -1. Seems pretty overwhelming, but step one is just figure out what this inside value is. Not worry about the fact that I'm even dealing with a composition of functions. I have this g and this f lying around. I just want to find what h of -1 is. So what is h of -1? Maybe it'll help to make these graphs a little bigger. It's a little bit strange, something, and I pulled this from the book. I don't know why they designed it for this way, but this is my f graph. This is my g graph. This is my h graph. So what is h of -1?
Is it 1?
Yep. So coming to my h graph, my x value would be -1 there. And so my h value of my graph at -1 is 1. So now my question becomes, okay, I know, maybe I'll do this on the next slide. I know h of -1 is equal to 1. So now my question becomes, what's f of g of 1? I know what h of -1 is now. So what do I do next?
Would that be 1 again on the middle graph?
Yeah, so we're looking at the middle graph. That's my g. I want to find g of 1. Okay, here's where x is equal to 1. I trace it up to my graph. This also returns a value of 1. This doesn't seem like the most exciting example, but gets the point across. So I know my g of 1 is also 1. So since I found that result, my question becomes a little simpler. I know my g of 1 is 1. So at this point, we just have a question that we've seen before. All I have to do is find my f of 1. What is f of 1?
Which is also 1.
Yeah, right. Looking at my f graph, I plug in 1 for my function. That is going to be associated with this point. And so f of 1 is equal to 1. So at the end of the day, f of g of h of -1 is equal to 1. And I kind of been using it along the way, but the language, like going back to just even reading this, if I were to read this, this is called g of f of x. Yeah, that of is kind of what's inside the parentheses. I don't know, it's kind of a subtle thing, but maybe it helps you be aware of why I'm saying that of. Great. Any questions about that?
Would the answer just be written as how you have it of
You could write it like this. If you wanted to be extra careful, you could say, okay, I went through this entire process, but at the end of the day, what the question was asking me for was this. I'm good with either. This is probably what a way to write your answer for someone outside of mathematics. This is perfectly fine inside mathematics, because all you're saying is this is equal to this is equal to this, and boom. Yeah, James, this is very much like a Russian doll, right? You kind of look in the middle and you say, oh, what's the beginning? Oh, -1. Now I put another doll together. Now I put another doll together. I like that. Cool. Moving on. One last example, and then actually this is it for the section. This is composition of functions. We'll be done with it. I'll let you guys practice this for a bit. Then we'll move into inverses. And I think we will be back on schedule, even though we lost that day, which is nice. Okay, so this question is kind of a puzzle the first time you see it. If I wasn't about to go through it, or you haven't ever seen it before, you might sit and think about it, I don't know, an hour or so. But there is a very specific trick to solve these types of problems. So in short, what this question is asking is saying, I have this function h of x. I want to break it into pieces. I want to build my Russian doll of what's the inside value, and then what's the overall doll that's kind of encapsulating the whole thing. And so there are technically a lot of answers to this question. You could FOIL this out and maybe find some weird result, but there is a very easy way to kind of, I don't want to say easy. Easy is always a dangerous word in mathematics, but there's a fairly simple process, a formulaic way to always find what this h of x is. Always find the two pieces, what's my g and what's my f. So maybe someone who's watched the video, or maybe someone who's really good at puzzles, what would be an f and a g that would get me this result?
X to the 5th power, and then 2x minus 3.
F of x is equal to x to the 5th. And g of x would be equal to 2x minus 5. Now, how did you magically pick those things? I think this is the f. No, this is the g. That's right. You're right. That's absolutely right.
So looking at like kind of that f of x, right? Now that it's going to be x raised to the 5th power. Like, we don't need to do any crazy arithmetic. It's just kind of recognizing the pattern from it. And then if we're saying that g of x is going to be 2x minus 5, and then plugging it in, we're just going to put that in parentheses 4x, and then it's raised to the 5th power.
Yeah, that's a good way to think about it. How I think about it is kind of a big picture, small picture. Kind of essentially exactly what you were saying. So big picture, what's happening overall to my function, I'm taking something to the 5th power. Yeah, that something is a little bit more complicated than just being like, oh, it's x. But essentially at the end of the day, that's what I'm doing. I'm taking something to the 5th power. And so that is what my overall function, my f, should be. And then what is that something? That's this 2x minus 3. So that is kind of the pattern that shows up. Like I said, there are other answers to this. Honestly, you could like say f of x is x to the 3rd, and then g is 2x minus 3 to, like, I don't know, something weird 2/3. But don't overcomplicate it. Kind of just focus on this big picture, small picture. And honestly, once you do like 4 or 5 of these questions, it wouldn't take that long to do 4 or 5 of these questions. You could probably do these questions in the sleep of, or in your sleep of, oh, that's my inside, that's my outside, boom, thanks for the 3 points on the exam. This question will show up on the exam. It shouldn't take you very much time. Cool. Any questions about this? So that's it for 6.1. So the worksheet, I think, in the module actually has 6.1 and 6.2 thrown together. The first page is entirely 6.1. Actually, let me confirm that. Pause. Yes, exactly. Each input is mapped to exactly one output. So if I had like one getting mapped to 2 and one getting mapped to 4, that's bad news. And so 1-to-1 is almost the exact same definition, but in reverse. The 1-to-1 definition is that every single output should get mapped to the same, or every single output should get mapped to a single input. So for example, what we see, are both of these 1-to-1? Oh, I messed this up. Let's change this one slightly. So this question is not a function because I have -2 mapped to 5. I have -2 mapped to 7. Not a function. We usually don't talk about 1-to-1 without a function, but for the sake of example, we're going to do that in this case. This is also not 1-to-1 because the reverse. I have 7, my output is getting mapped to -1. I have 7, my output is getting mapped from, not to, mapped from -2. So that's how I break the definition of not 1-to-1. And that's because I have -1 going to 7. Wow. And I have -2 going to 7. So very similar to the function definition, just instead of worrying about inputs, now we're worried about outputs. So is the thing on the right over here, is this a function? number 2. Again, just a function. We're not talking about one-to-one yet. Is this a function? Question 2.
Yes.
Yeah,
Yes,
right.
it is.
1 goes to 1, 2 goes to 16, 3 goes to 81. We're all good. It is also one-to-one because, well, for starters, I have 3 different outputs, so there's no way that I would have 2 different inputs getting mapped to the same output. And that's kind of the shortcut. We had that shortcut with functions of, oh, honestly, if all of my x values are different, I'm set. I don't really have to worry about this overlapping of inputs. And same thing here. If I'm looking at one-to-one and all of my outputs are different, well, there's no way that I'm going to get 2 different inputs getting mapped to the same output. So you might be thinking to yourself, why do I care about the definition of one-to-one? Honestly, I would argue that it's a little bit more important to the definition of a function. We kind of threw out the definition of a function, said, trust me, it's kind of important, but we didn't really go through any examples of why that actually matters. Well, the reason why one-to-one is very important is because a function needs to be one-to-one in order to find an inverse, which actually kind of makes sense if you think about it. So when I'm trying to find an inverse, I'm trying to say, okay, I have my result. What did that result come from? Is there a way to kind of undo my mapping? And so if I were to ask you and say, okay, my output was 7, like we have this function right here. It is actually, it's not a function, but I have this function here. And I said my result is 7. And I asked you, what is the input? Well, you would say, oh, it could be -1, it could be -2, I'm not really sure. Where if I came to this question and said, okay, my result was 16, what was my input? You'd be like, 2. Yeah, there's no question about it. There is no other input getting mapped to the output. So if we're thinking about kind of just inverses as far as numbers go, well, here, if I'm looking at a function, I know if my input's -2, I get a result of 2. If my input is -1, I get a result of 6. If my input 0, I get a result of 8. So if I want to find the inverse of this list, I kind of just flip everything. Because an inverse is, now I'm starting with the output. Well, what was my actual input? So if my output is 2, my input was -2. I plugged in -2 to get that result. If my output was 6, what did I plug in?
-1.
Mhm. If my output was 8, what did I plug in?
0.
So this is the idea when we're just looking at a list of inputs and outputs for inverses. You're just undoing. Function tells you, okay, I plugged in something and I got a result. An inverse says, okay, I know what my result is. Well, what did I actually plug in at the very beginning? So this is list form, a little kind of abstract to think about. It might make a little more sense when we actually get into an example of finding an inverse. So in fact, let's skip to that. There is a property about inverses that we'll talk about after I do the slide, but let's find this inverse. So here I have a function. It is one-to-one. There are ways to kind of check that, but for now, just trust me, it's a one-to-one function. Every input would get exactly one output. And so if you gave me an input, if you said, oh, I want to find f of 2, well, I could find that for you actually pretty quickly here. I plug in 2 to my function, I would give you the result. But maybe I want to build a function so that you could give me any result, and I would say, this is what your input was initially. This is what you started with by plugging it in the function. And so we do that by finding the inverse. The inverse is also a function. It's an undoing function. So concepts a little bit kind of murky, I get that, but the process honestly isn't too terrible. Does anyone know how you find an inverse? Or I guess I go through it in the video, but maybe there's different strategies. Does anyone have a strategy to find an inverse? There is a very specific process that actually isn't too terrible. My function here. Maybe you didn't get to this video, that's fine. The process is, okay, I have this function, I'm gonna put a y, I'm gonna replace f of x with y. It's kind of arbitrary, truth be told, you can leave it as f of x, it's just kind of hard to keep the algebra straight. So first step, I just take f of x and make it y. Next step, I flip my x and my y. This step is not technically mathematical, but I'm trying to undo this function. And so if I undo this function, well, I should be able to take an output and get the result of what my input is. So flip it. All I did was take my x and my y, put them in opposite parts. And now at this point, I just solve for y. And that's it. That's honestly the entire process of finding an inverse. I replace f of x with y. I don't really have to do that, but it makes the algebra easier. Flip x and y, solve for y. Three-step process. Maybe it's a little bit difficult to solve for y, but that's the overall process of finding an inverse. So how do I solve for y?
You'd add 6 to both sides and then divide by 2.
Mhm. And that's it. That's my final answer. That's my inverse. The fancy notation is, okay, y is not entirely true. So how I write an inverse at the end of the day is I do the exact same thing as a function. I just put this negative there. So this is the definition of an inverse, or how I indicate this is an inverse. And that's my final answer. So this would be my answer for the inverse. Everyone tracking with that?
So the 4 has nothing to do with anything?
Oh, yeah, sorry, that's the last part of the question. But as far as
Oh.
finding the inverse, this is my inverse. We'll
Okay.
find f of -4 in a sec, but everyone good finding the inverse, I suppose I should have been more clear. Cool. Finding the domain and range of both isn't too hard. In fact, we've done it before. So to find the domain of f of x, well, that's all real numbers. To find the domain of the inverse, in this case, it's also all real numbers. Those are both type 3. And then a cool property of inverses is that the domain of the inverse is same as the range of the original and vice versa. I cover that a little bit more in the video, so if you want to track that down, that's great. But for the sake of time, we just don't have a whole lot of time to go through this domain and range inverse. But yeah, so to kind of cycle back to Courtney's question, how do we find f inverse of 4? Sorry, should always have the chat popped out. Either way is fine, Austin. So Austin was asking, can we simplify this further and make it x over 2 plus 3? Those are arguably just as simple as this, in my opinion. So either way is fine for me. Good question. Well, how do you guys think I find f inverse of 4?
Like in 4 for x?
Yeah, right. And this is again kind of a function thing. It's just more so now we have the inverse, so I have to plug the 4 into the inverse as opposed to the original function. Yeah, whatever. So if I plug in 4, actually don't like that. Let's make it flow a little better. And then I just do some simplification. 4 plus 6 is 10. So f of -4. F inverse of 4 is 5. what do we think f of 5 is? And I don't want you to plug it in or do any mathematics. Just think about this. What do we think f of 5 is? If I plugged, so we can kind of see what I'm typing. What is this value?
Would it
I
be
argue
4?
we could answer that question without doing any further mathematics. Yeah, it's not too hard, but pretend that we don't have that original function.
Would it be 4?
Yeah, right. It's that idea of inverses undo it. So if I know that my f inverse of 4 is 5, that means f of 5 is 4. Kind of that reverse flipping thing that we saw with our lists. Any questions about that?
So our final answer is f of 5
For to answer this guy,
yeah.
it's just 5.
Okay.
I was just kind of doing a thought experiment there. This is your final answer to that question. The domain of both of them is all real numbers, right? Because this is a type 3, this is a type 3. And so a cool property of inverse is that the domain of the inverse is the range of the other, and vice versa. So since I know the domain of my inverse is all real numbers, my range of my original function is all real numbers. Since the domain of my original function is all real numbers, the range of my inverse is all real numbers. I go into a better kind of example walkthrough in the actual video, so I'd recommend watching that, but that is how you find your domain and your range. Cool. This question's hard, so I might set it up in a bit, but I do want to talk about one last property of inverses. So, everyone good with at least the first question here? Okay. So, one of the cool properties of inverses is that it's actually not too terrible to check your answer. This process can get pretty involved. Like I said, this is a pretty involved question itself. There's a lot of moving pieces. We have to solve for fractions, multiply things over, factor it, so on and so forth. So there is a lot of places you can make mistakes. A property of inverses, and actually makes sense if you think about it for a little bit, is that if two things are inverses of each other, well, you can take one function, use the composition of functions and plug it into the other, and you should get a result of x. Seems kind of weird, seems kind of magical, but actually when you think about what you're doing, well, if you're plugging an inverse into itself, you should return the original starting point. So if I'm trying to find g of f of x and their inverses, well, I should get back to what I started with, which was just my x, my original input. So to see it in practice, question here, is f of x and g of x, are these inverses of each other? We check them by plugging in my g of x into my f of x. So what is f of g of x? Or even more magical, the other direction works. So let's say that you don't want to plug in f of g of x for whatever reason. You can go the other direction. Either way, you should return a value of x. So the order doesn't necessarily matter with this. Okay, so how do I find f of g of x?
You'd write it out as 2 times 1/2 x plus 1 close parentheses minus 1.
Yep, so I'm going to take my g of x, which is this guy. I'm going to plug it in for my x here. So then I'll get 2 times 1/2 x plus 1 minus 1. This is my g of x here. Alternative option, you could take the f of x, this guy, and plug it into your x and your g. Either one works. Honestly, that probably is a little simpler than what I did, but my direction's really not that difficult either. Okay, So if I do 2 times 1/2, that just cancels out. So I'm left with x plus 1 minus 1. So my answer is x. End of the day, you say yes, they versus. Any questions about this? Cool. So bonus point time. So I'm going to put you back into your groups. If you are able to find the inverse of this function, and by you, I mean the entirety of your group. If you're the only one to turn in the inverse to this question, I'm not going to give you any bonus points. But if you're able to, you and your group are able to find the inverse of this function, it's tricky. It's not an easy question. It might take the rest of class, might take a little bit longer than that. I'll give you a bonus point on the take home. If you're able to also find the domain and range of your inverse, I'll give you another bonus point. So you can get up to 2 points back. If you magically get 100% on your take home without the bonus points, I'll shift it to the exam. I'll figure out where to kind of put those points if necessary. So hopefully this encourages you guys to talk to each other, but also be aware that the process of finding an inverse itself isn't too difficult. This question, the algebra comes a little tricky. So you're probably going to have to talk to everyone and make sure they're getting it. If you don't want any bonus points, honestly, you can call it a day and say, okay, well, I got the first part. Maybe I'll do one practice problem of these inverses on my own. But I imagine some of you at least would like to get a bonus point back on the exam, or the take-home exam, I guess, more specifically. Cool. And then, yeah, whenever you're done with that, you submit it. Maybe in the notes of the in-class say, oh, I actually found the bonus point. We actually found my inverse as a group, just so I know to kind of look for it as I'm grading that. Are there any questions about this or stuff inside of content or stuff out?